Good afternoon. We'll be doing chapter 5, Inductive Inference and its Types. Part 1. Let us understand the need for induction. Before we go to the need for induction, we must understand the limits of deduction. Let us see what is deduction. Deduction is formal process. Let us take an example. All A is B, X is A, therefore X is B. Here A and B are classes, whereas X is an individual. Now, deductive argument determines the necessary relation between the propositions irrespective of their contents. Here, in deductive argument, there are three propositions where the first two are the premises and last one is the conclusion, which is inferred on the basis of the first two proposition. The first two propositions are all A is B, X is A are the premises and X is B is the conclusion. That there is a relation, necessary relation between the premises and the conclusion, that is of implication, irrespective of their content, means irrespective of what the argument is made about. Means it does not depend upon the subject matter about which the argument is made. The relation does not depend upon the content. Now next, it begins with certain propositions which are assumed to be true. From this we infer the truth of the proposition which implies them. Means what? Here the premises are assumed to be true. So from this we infer that the conclusion is also true, because the relation between the premise and the conclusion is of implication in a valid deductive argument. But we cannot determine the truth of the propositions offered as evidence for the conclusion. Now in this argument, what is offered as evidence is all A is B, X is A are premises which are offered as evidence for the conclusion X is B. Here these evidences, its truth cannot be known, cannot be determined by deductive argument. And it does not provide the basis for determining the truth of the premises. There are no basis for determining the truth of the premises in a deductive argument. We already know what is deductive reasoning. It is a formal process in which we pass on from a more general proposition to a less general proposition and finally to a particular proposition. Here, in a valid deductive argument, the premises imply the conclusion. The premises are assumed to be true, and so the conclusion is true. But we also know that in a valid deductive argument, if the conclusion is false, then one of the premise is false. So the deductive argument does not give us the material truth of the conclusion. If we try to find out the material truth of the conclusion, whether in reality the conclusion is true or false, then it will lead us to infinite number of arguments. Let us understand this with an example. All men die. Amit is a man, therefore Amit will die. This is a deductive argument in which Amit will die is the conclusion which is inferred from all men die. Amit is a man. If we want to find out the material truth of the conclusion Amit will die, we will have to prove the premise all men die is true. To prove that all men die is true, we will have to frame another deductive argument saying that all animals die, all men are animals, therefore all men die. Here all men die is the conclusion which is inferred from all animals die and all men are animals. To prove the material truth of the conclusion all men die, we will have to prove the proposition all animals die is true. To prove the proposition all animals die is true, we will have to frame another argument, which is deductive argument, saying that all living beings die, all animals are living beings, therefore all animals die. Now here all animals die is inferred from all living beings die and all animals are living beings. To find out the material truth of the conclusion all animals die, we will have to prove the proposition all living beings die is true. And to prove that all living beings die is true, we will have to frame another deductive argument, and this will lead us to a long chain of reasoning. Ultimately, we will come to a proposition, general proposition, whose truth cannot be determined in this manner. Such a general proposition is called synthetic proposition, because the scope of this proposition is not limited to any given region of space or period of time. We already know that the less general laws are deduced from more general laws. But let us not forget that we can deduce the truth of the less general propositions from more general ones, provided we assert that the more general propositions are true. And to find the truth of such more general propositions, we have to rely on observation and experiment. The process involved in establishing the synthetic, that is more general proposition, is called induction. Hence, there is need for induction. We have seen that why there is a need for induction to find out the material truth. So, what does induction or inductive inference? Its aim is to establish the material truth. The conclusion, you know that in an inductive inference, the conclusion asserts something more than what is asserted in the premises. Means it goes beyond the premises. It gives us new information. Third, it is an inference which proceeds from observation of some instances to a generalization which includes all the instances. Now let us take an example. You can see four metals here. They conduct electricity. Example, copper conducts electricity, brass conducts electricity, iron conducts electricity, aluminium conducts electricity. Therefore, what will you conclude? That all metals conduct electricity. This is an inductive inference, where we pass on from particular to a general proposition, where we observe few metals like copper, brass, iron and aluminium that they conduct electricity. Therefore, we conclude that all metals conduct electricity. Symbolic expression of inductive argument is P1, P2, P3, P4 till Pn has the quality Q. Therefore, all P's are Q. And inductive inference not only establishes the general proposition, but also the particular proposition. This you have to note it down. The types of inductive inferences. First is the simple enumeration. Second is analogy. Third is scientific induction. And fourth is hypothetical deductive method. So, there are four types of inductive inferences. Let us understand induction by simple enumeration. It is a common man's method of arriving at a generalization which is based on observations. On the basis of observations, only we generalize here because it is a method of induction. And let us understand this with an example. I observed the first rooster. It has comb on his head. I observed the second rooster. It has comb on his head. I observed the third rooster. It has comb on his head. Therefore, I conclude that all roosters have comb on their heads. Let us understand the definition of simple enumeration. It is an induction in which the generalization is supported by only positive instances and no contrary instances observed. So we are seeing only uniformity in our observation and no contradiction. It consists in saying that what is true of several instances of a kind is true of all the instances of that kind. What does this mean? That if you are observing few roosters, then you can only conclude about roosters. Symbolic form is that all observed P's are Q, no observed P is non-Q, therefore all P's are Q. Let us understand the characteristics of simple enumeration. The first is uniform or uncontradicted experience. Simple enumeration is based on the tendency to expect that what is true of the observed instances will also be true of the unobserved ones. This shows that the ground of generalization in simple enumeration is uniform or uncontradicted experience. Our experiences shows that certain properties are found together, that is comb. Having comb always goes with roosters. Blackness always goes with crows. Fawns always goes with rose plants and so on. And we have not come across any contrary instance. So we expect that what is true of the cases within our experience will always be true. Second is belief in uniformity of nature. The method of simple enumeration supposes that if there were any contrary instances, we would have come across them. Further, if we are inferring certain properties of unknown cases because we have found them in the known cases. So the generalization is based on the belief that nature is uniform. This is the principle of uniformity of nature on which the simple enumeration is based. Third, lack of analysis of properties. In simple enumeration, we do not analyze the properties of the observed instances. That is, we do not attempt to find out why certain properties go together. In the generalization about roosters, we have not cared to find out why the property of having comb goes with the rooster. In fact, if we were to do so, we would be conducting a scientific investigation. Last is low degree of probability. A generalization by simple enumeration is based on the mere uniform experience. So if we come across any contrary instance, it will be rejected. And that is why it is said that as opposed to generalization in science, generalizations established through the method of simple enumeration have a low degree of probability. That is, we take a leap in the dark, that is, we jump from few instances which are known and observed to all instances which are unknown or unobserved, which is technically called as inductive leap. And here we do not analyze the properties. So we have low degree of probability. Now, value of induction by simple enumeration also depends upon the wider experiences. Means the larger number of instances observed with uniform and uncontradicted experience, the more reliable your conclusion will be. Second is variety of experiences. That is, instead of observing maximum number of instances in one part of the world, it is better to observe in different parts of the world. With and such variety of experience with uniformity and uncontradictory instances will make the conclusion more valuable in simple enumeration. Third is resemblances, that is value of simple enumeration is also affected by the nature of resemblances. So besides the rooster having comb, other characteristics also which resemble have to be observed in all roosters. Like how we observe in the case of a crow, besides blackness, we observe its pointed beak, clawed feet, etc. So that the conclusion will be of more value. Now we come to the second type of induction. It is also the common man's method of induction where one proceeds from particular proposition to a particular proposition. In the case of simple enumeration, it was a common man's method of induction, but where we proceeded from a particular proposition to a general proposition. That we observed one rooster, it is having a comb, to we proceeded from one rooster to all roosters. But here we are proceeding from a particular proposition to a particular proposition. The definition, we may define this type of induction, that is analogy, as an argument from partial, that is known resemblances, to further resemblances. That is to say, two things resemble each other in certain characteristics or properties, and if one thing has an additional characteristic or property, then the other is said to have that characteristic or property. Let us take an example of analogy. College A and College B resemble each other in certain characteristics. Let us see in what characteristic they resemble. First is that the management in College A and College B is X. Second, both the colleges, that is College A and College B, they have qualified and trained teachers. Then College A has good facilities, then College B also has good facilities. Then College A has commerce faculty, then College B also has commerce faculty. Now, what is the additional quality of College A is that the result this year is cent% in College A. So, what will you conclude about College B? That the result this year is cent% in College B. When we conclude in this manner, on the basis of the known resemblances, we go to the further resemblance that the result in College B is cent%, then we are using the method of analogy. Now we come to the symbolic form of analogy. P1 is observed to have property R1, R2, Rn till Rn number of properties. P2 is also observed to have property R1, R2, R3 till Rn. Now, P1 has an additional property Q. Therefore, we conclude that P2 also has the property Q. Let us understand the value of analogy. It is based on the basic three conditions. First is relevant and important resemblances. When the known resemblances consist of important properties, the conclusion of analogy has a high degree of probability. Let us understand this with an example of Lowell's analogy. Lowell says that the Earth and Mars resemble each other in certain characteristics like atmosphere, water, and moderate temperature. And the Earth has an additional quality or property that there is life on it. So he concludes that there is also life on Mars. This analogical argument has high degree of probability because the resemblances which he talks about, that is atmosphere, water and moderate temperature, are important ones because these are essential conditions of life on the earth. Now the second condition is that important differences. When the known differences consist of important properties, the conclusion of analogy has little probability. Let us take an example. If you would say that man and monkey both have two legs, they resemble each other. That is, they have two legs, two eyes, two hands, one nose, two ears. And the additional quality or property possessed by man is that he can read and write. Therefore, we conclude that monkeys also can read and write. Then our analogical argument will have little probability. This is because though there are many similarities between man and monkey, but the difference is very important one between man and monkey. That is, man is rational, whereas monkey is not as rational as man. Therefore, the analogical argument will be weak or bad one. We have to note here that the conclusion established by analogical reasoning is always probable and never certain. And last is the nature of conclusion. The conclusion should assert the minimum that is justified by the evidence. Let us understand this with an example. Resemblances between the Earth and Mars justifies the inference that there are living beings on Mars. But these do not justify the conclusion that there are human beings on Mars. Merely because Mars is alike Earth, in the presence of the basic conditions of life, we cannot infer that life on Mars has developed in a similar manner. Hence, this analogical argument will have little probability. So we have understood here two types of induction, that is simple enumeration and analogy. Thank you.